Hey everyone, so today for Data Challenge 6, we're going to be going over it, and this is on the Chicago Divvy Bike bike share data system, right? So Chicago is a bike share system. It's owned by a company called Divvy, and so this is a data set that's from taken over all of 2018. So it's all the rides taken in 2018 on a Divvy bike in Chicago. So it's pretty cool, like really rich data set. And so today we're going to be working with a reduced version of it, but as the semester goes on, we'll be working more and more. And so the goal of this lesson was on some of our extending some of the questions we had about feature engineering, right? So we have aspects of our data set that some may be useful in their current form, some less so. And we want to then create new features, new column that allows us to sort of further understand relationships in the data, as well as understand, say, examples of who's using the bike share, how are they using it, how long are they using it for, so on and so forth. And so I already loaded bikes into my environment, so go ahead and run that, but it'll take 30 seconds, a minute. So mine's already in it. And so let's go ahead and just explore as usual. Of course, make sure your libraries are loaded as well. And so we'll start by just looking at a head of bikes to get an idea, well, what's in here. And so we can see we have some start times and we have some end times. So these are some things we probably want to convert to date times, and we can probably make a more useful feature of total ride time, right? So the end time minus the start time to get an idea of how many minutes they rode the bike for. Bike ID, station name, user type, gender, birth year, tourist. So definitely some other things that I can see, like for example, birth year. We might want to convert this to an actual age to make it easier to understand, because people intuitively know 18 years old versus someone who was born in 2001. So some features that we're going to make, some changing of data types we're going to have to do in order to make those features will be the general point of this lesson. We can do a couple more things. Let's do a quick just summary too of bikes. The idea, well, what's our data present? So another thing that I kind of want to point out here, birth year. So we see a min birth year of 1900. And so this is probably just people who are being lazy, or just sort of don't want to input the right information purposefully. But I highly doubt there's someone who's 118 years old out renting a bike. That'd be great if there was, but probably not. So some outliers that we might want to get rid of. Some other interesting things, bike ID is currently in a number. And so this is something that sort of is a point of my next question. So bike ID is being listed as numeric, but it's not actually numeric, right? Numeric data sets are for sort of more continuous variables, like how you could have a range of weights. But bike IDs are actually in reference to a discrete bike, right? So each bike has its own unique ID. And it's not possible to have, say, half of an ID, right, to be 1.5, for example. That just bike doesn't exist. And so this is an example of where our sees numeric data, or it sees sees numbers that was brought in, it automatically makes it numeric, when in reality we want it to instead be a character string or a factor. So R doesn't think that you can actually do math on this, right? So what we're going to do is actually go ahead and convert it to a factor below. And so this is like that super straightforward stuff, just like we were doing in class, where you just say bike's ID. So you're going to overwrite your bike ID column, and you're just going to create a factor with the existing bike ID column. ID. And so go ahead and run that. And so one of the nice parts about factors, as we talked about in class, is you can easily just call a quick summary on a factor, bike ID, and it'll give you back then this list of bike ID number right here, so 6234, and this one had 74 rides, and bike 5636 had 70. So it'll go through, and since it knows it's like a discrete group, a factor, it'll go through and count how many times that ID popped up in the whole data set. So this is really great, and it's a step towards being really useful. Like say, for example, you were in charge of managing these bikes, and you wanted to know, say, which bikes at the end of 2018 needed to come in for maintenance. Well, if you said you had a threshold of, hey, bikes that had over 50 rides need to come in, you could go and get a list of all the bike IDs that have over 50 rides and be like, go find these, bring them in, and we'll maintain them. So this is part of the reason why factors start being more useful in R, as well as in the fact we want to make sure these are discrete categories. Each bike is its own discrete group. So we've answered that. We can also convert a couple other things to factors here, both gender and user type, because it allows us to quickly then count up how many observations are in each group, right? And so we do this the same way: bikes, gender, and just factor, bikes, gender. And then same with bikes, user type. And then we'll make that from a factor, bikes, user type. And so this will overwrite then the existing characters columns with a factored column for both gender and user type right here and there. And so the nice part is that now we can go and just do a summary of bikes, and just how we called it an individual column, it'll then give us our output here about how many observations we're seeing for each group. So for customers, we see that there's 57,000 customers. These are people who are just showing up and just buying a single ride. For subscribers, we're people who have bought like a year-long subscription and then just kind of can use them at will. There's another neat thing that I saw here in gender. So females, we see 25,000 females rented these bikes out of this data set and 77,000 males. But we have an interesting thing where we have over 50,000 NAs. So this is a question of just, were females just less likely to input their gender into this data set or into the app when they were going and checking it out compared to males? Or is it that there's fewer females riding? These are things that would prompt future questions that sort of you would want to explore more deeply in data and actually go out and maybe say do surveys of who's actually using it to figure out, are you actually not getting enough females on these bikes, and how could you get more females riding them? Or is it just that females are much more likely to just quickly put in an NA and not provide their gender? So those are kind of future questions that we're not going to worry about too much, but I do want to point out that we have these as NAs and we want to just leave them as NAs. We don't want to actually ditch them at this point. So now what we're going to do is we're going to make a new column called trip time. And so there's two steps. So first, what we want to do is convert start time and end time columns to date times. And so to do this, we use our lubridate, right? And I recommend using a test vector first. And so in this case, we're going to do XXX. And then there's a bunch of different lubridate functions, right? So we saw MDY or YMD. And these all depend on the format of the dates you're converting. So what let's do is let's look at the head of bikes start time. And so we see our date and time formats. And what we see is that this could be the month or the day, and this could be the month or day. This is obviously the year. And then we have time, but we don't have the full time. But let's start by figuring out if this is month or day or this is the month or day, because the order could be either. And so normally an easy way to kind of figure this out is you want to look for any time to where one of either the month or day potential ones is over 12, because then you automatically know if it's over 12, that's the day in there. So we can just look at the tail. And here we can see, okay, this clearly confirms the format. So this is obviously the month, because then this is obviously the day. There's no 31, we don't have a 31th month. And then year. So this is good. So now we know our format is, the start of it is month, day, year. And so we can see now a bunch of different potential functions pop up all within lubridate. And so we have more than just month, day, year. We also have time. And so these underscores allow lubridate to also incorporate times. In this case, if you have just hours, hours and minutes, or hours and seconds. In our case, we have just hours here and minutes here. So we just need HM. And so we can take then our bike's start time and see what it does. Okay, so no error, so it seemed to parse correctly. The problem is if you get this format wrong, it will probably still parse, or it'll give you parsing errors and just replace a bunch of stuff with NAs. And then you need to go back and re-import your data. So this is why it's really good to work with a test vector here. And so we can just throw XXX into the console. And so we see that, hey, now we have this huge list of date times. It has a time zone, and they're all now in a standardized format too. So it even shifted around the format for us. We can do another thing, do a glimpse on XXX. And so we see here that there's this POSIX, which is basically a date time object. So it's saying, yes, we successfully converted this to a date time. But let's now go and overwrite our existing character start time and replace with the date time. So we'll just do bikes start time. And now we can do the same for end time. End time. The date format is the same. Bikes end time. And so we can go ahead and run both. And now what I want to do is recheck the data frame, bikes with just glimpse. And so what do we see here? So we see that, obviously none of this stuff changed, but now we have these specific data types, date time right here. And so this is really powerful because now we can start doing math with these date times because R knows how many seconds or days or minutes are underlying all of these. So we're going to now use mutate, and we're going to create a new column called trip time. And so all we do is, as we want to overwrite bikes with bikes, and so we're going to take bikes and then we're going to mutate something. And if we remember, our mutate format is always our new column name. So in this case, trip time, and what it's equal to. And so this is just whatever math you're doing columns on. And so here what it is end time. And we're just going to subtract off start time. And this should give us then the number of minutes between these two intervals. And so let's go ahead and also just glimpse just to see what that looks like and make sure it worked. Cool. So 13 minutes, 15 minutes. And so this makes sense here. So this ride started at 2 a.m. or 2:33 in the morning, and it ended at 2:46. And so obviously there's a 13-minute difference. This ride started at 8:04 a.m. and ended at 8:19. So that is a 15-minute ride. So clearly this worked well. And now we are on our way to having a new useful feature. How long was a ride rather than just start times versus end times? And so the next step is to convert it to numeric, because remember, we can't actually do math on, we can't divide things by these time variables. And so we can just go and just then convert, as we have been, bikes trip time, and then as numeric bikes trip time. And so what this will do then, if we just look at a glimpse again, is now this is showing as a double, so a number. So we can start doing math on this. If you went and say did a summary of bikes, trip time. So we see our max is 120 minutes and a minimum is 1 minute. So someone went, grabbed this bike, literally spun it around in a circle and just put it back in the station. They were just like, no, this isn't for me. But some people are taking these on pretty long journeys. The mean is 21 minutes. So most people are doing pretty short rides on these, which is kind of the point, right? Okay, so now we have a new column. We started exploring it. So we started exploring our column. Sorry, my mouse just stopped working. Okay, well, back to the keyboard. Sorry, I was using an external keyboard there, which now I can't use for some reason. So now that we have our new column, we can explore it. So we started exploring it through, summary bikes, like that. But then we can also do a quick histogram of trip times to get an idea. And so in this case, we can do a quick R-based one, like base R1, bikes, trip time. And that's fine for our purposes. And so what do we see here? So we see a big peak here, so frequency. So there's a vast majority of the rides are, under this 20-minute mark, but some are going farther and farther out. So this seems like a nice, pretty reasonable feature, but now it's much more useful than having these start and end times. So we have this useful column, get from some inference by plotting. So first what I want to do is let's look at how basically we have these different tourist versus non-tourist locations. So let's see if trip times differ between these two locations. So we'll make a box plot. ggplot, bikes, and then our aesthetic, and then in this case, X we want to be equal to if they're a tourist or not. Oop, just tourist. And then we want our Y to be equal to our new feature, trip time. Close that up, and then box plot. Okay, what do we get? So a lot of outliers, which doesn't surprise me of this many data, this big of a data set. But so in terms of tourist locations, we see individuals who are at sort of renting a bike from a tourist location are taking a lot more time. So their mean ride time is 25 minutes compared to those who are grabbing them from non-tourist locations are much shorter rides. And so this actually isn't that surprising. These are often tourist locations are often in parks, or maybe they're going from one tourist location to another that's a lot farther versus someone grabbing a bike in their neighborhood and running a quick errand that maybe lives in the city. So we see kind of these two different user groups potentially, or at a minimum, just locations very much differ in terms of how long they use it, but then also how much variation around that time is. Some of the tourist locations really take the bikes for a long time. There could be a number of reasons for that. But so it's pretty cool, right? So it kind of gives us some inference about sort of how different locations, how location is affecting how much time they spend on this. We can also do another thing to kind of further dig into this. So basically how different customer types affect ride time. So these are potentially subscribers versus non. So subscribers are the ones that probably live in the city, where the nons are the ones that probably don't live in the city or are really infrequent users. And so I'm going to be just lazy here and just copy and paste the box plot. And now we're just changing this to user type and run that. And so here's what we see. So subscribers, again, probably more local riders, they're taking much, much shorter rides. So they're just grabbing these bikes, they're doing a quick ride, and they're putting it away. What we see is customers, the ones who are using it and buying it, say, for 30 minutes at a time, are much more likely to take longer rides. And there's a lot more variation around that too, right? So a lot of them are taking really long rides. And so again, these are probably people who are coming in from out of town. And they're using this much more for fun rather than the subscribers who are using it more for utility. They don't want to own a bike themselves, but they still want to use one to get around the city. So they just hop on this, quickly get to where they need to go, and then put it away. So this is great. This is like we're already using these features to make some inference about how customers are using these bikes. So those are our two like new features, or our one new really useful feature. We'll be making more. For the bonus question, we're actually going to make one more. And so this, what I'm asking for is create an age column, right? Something more useful. And then this way we can see how ride time varies in response to riders' age with a scatter plot. And so we already know we might run into the issue of some rider ages being improper. And so what we're going to do is we're going to have to use a mutate, as we have been. So bikes, and we're going to mutate, and then we're going to create a new column called rider age. And so to do this, all we have to do is we know that this is the 2018 data, and then we just subtract off rider age. And that's all we need to do. And what that will do is now do 2018, say, minus 2001, which will give us a rider age of 17. And we'll do that for every element in that whole column. And so let's go ahead and run that. Rider age. Oh, that's because I'm making the rider age column. Sorry. What I want to do is subtract off birth year. And what do we see? Okay, so we have bikes. So we can look at a summary of bikes. So rider age, the minimum is 15, so that seems pretty reasonable. There's no like 5-year-olds riding around in these things, but yeah, max of 118. So obviously there's some outliers. And so we can do this a couple ways. So we can figure out what we want to cut off. So we can do, say, like a hist of bikes, rider age, to get an idea of like how much data would we be cutting off. And so I think a pretty safe age to cut off would be just, say, 80. So there's some random ones out here. That's why ours plotting it. Like we have our couple riders at 118, but let's go ahead and just cut it off as 80. And so you could do this in a couple different ways. You could actually add a filter onto the end of this, but we'll stick to what we've been doing and just do a whole other filter. Okay. And so what we'll do is mutate. And then, I'm sorry, not mutate, filter. And then we want to filter rider age, and we want everything that is less than or equal to 80. One thing I'm going to point out is there's actually a ton of NAs. So again, a lot of people did not input their age, and our current filter is going to get rid of those. Because filter, if it sees an NA, will remove them, even without you explicitly telling it to do so. And so we're going to figure out how to deal with this later. But for now, I just want to point out that these NAs are going to disappear. And we might not want to do that because we might actually still want the other information. We still know aspects of their user type, what station they went to and from, so on and so forth. But for now, we'll just filter it at 80. And then we can do our quick histogram again if we want to explore that way. And so now our data set ends at 80. So now we have only likely real users that are inputting actual ages. Again, people could still be lying, but overall, we would assume that over 150,000, it's accurate enough. And so let's go now and plot and see how rider age influences how long they spend on the bike. So we'll do ggplot, and then we will have bikes as our data set. And for our aesthetic, we have our X is equal to rider age. And then our Y is equal to ride time or trip time. And then we'll do a scatter plot point. And then we'll also add on a fit line. And then geom smooth. And then, so we can do it either this regular way or we can do a fit line with method, but we'll just kind of let it run like this. And so what do we get? This might actually take a second to run, given it's a lot of data. So we're gonna have to sit here for a second. While that's running and building, one thing that I want to talk about here is this relationship. I've had a lot of questions on. Oh, well, here. So, well, here we can. So this isn't the best plot in its current form because there's a lot of data, so we'd probably want to downsample this. There's also a lot of noise, and I didn't fit the right fit line. So there's a couple interesting things here, though, that we can make with this current fit line. So it seems like there's a big decline in terms of how long the trip time is in these earlier ages. So someone in their early or mid-teens is going to spend a lot more time on the bike than someone that's, say, 25. After that, it's pretty flat. You do see, though, what appears to be a reduction when they're 60. This is fitting kind of a more unique type of model. Let's just fit like a regular regression model, though, to this for our fit line equals LM. And then that'll take another second to plot. But so I've had a lot of questions about how you determine what goes on the X and what goes on the Y. And so remember, your Y is your vertical axis. And in this case, what it is normally your Y is your response variable. So we'll just pop this up here in a second. But so the Y is what's being affected by X. And a good way to think about this is sort of the directionality of your question. So in our case, can rider age affect trip time? I mean, that's our question. Does rider age affect trip time? And so normally what you want is what you're looking at your question, is this affected, is normally your why. Another way to think about it is, can trip time affect rider age? No, absolutely not. And so in that case, you would definitely never have your trip time here on your X and your Y axis being the response of age, because age is not affected by trip time. Okay, so let's look a little more at this relationship. And so we fit just sort of our regression model, and this will take a second to sort of deal with that. I just made it full screen, but we can kind of already see what's going on, is that we have rider age decreasing to 80. There's a whole lot of variation, but we do see a generally negative trend here. And so as the trip time or as a rider gets older and older, they seem to spend less and less time on the bike. And so this is something to consider, again, if you're doing sort of more targeted marketing or something like that, and you want people to spend longer on the bikes, well, you might want to try to find ways to incentivize older riders to spend more time on the bikes, and then they spend more money. But this is just sort of a quick plot for now, and so you need to do more statistics and stuff, which we'll be learning later on in the year. So for now, that is the wrap up of Data Challenge 6. As always, feel free to drop me any emails with any questions.